Okay, so let's make a start. So right now we're going to be doing the energy topic. Previously last week we also covered a little bit about energy. So just as a quick recap, we talked about what energy was. It's just the ability to make something happen, and it has a unit of measurement called the joule, often shortened to just J. And this applies to all forms of energy. And last week we also talked about the different ways that energy can be stored, such as gravitational energy due to its height off the ground, or chemical energy due to the bonds within chemicals. And we also talked about how energy can be transferred from one form to another. Last week, we also did some calculations for what gravitational potential energy something has using the formula. Gravitational potential energy is equal to mgh. Today, we're going to be working on a new formula for another type of energy store, which is kinetic energy specifically. This formula, at first glance, it looks really challenging, but if we apply the FIFA method, formula, insert values, fine-tune, answer, we should be fine. So the important thing with this method is to substitute in any values from the question itself first, and then being able to rearrange things and clean it up later on. The reason why we do substitution first, remember, is because if you substitute, that's already a mark, but if you substitute correctly into an incorrectly rearranged equation, you lose all of the marks. So just to make sure you guarantee yourself at least some marks if we make a mistake later on with substitution, with rearranging, we substitute first. Now this is the formula for kinetic energy. How we find and calculate the kinetic energy store in a moving object. Remember, kinetic energy is the energy stored in an object that has motion. Kinetic energy is equal to 0.5 mv squared. In some textbooks or online, you might also see it as a half mv squared. Doesn't matter which one you memorize. Doesn't matter which one you memorize. The main idea behind this is 0.5 is exactly the same as saying a half. The reason why I would say that it might be a good idea to use 0.5 in the formula instead of a half is because since you're going to be putting it all in a calculator anyway, it's easier to put things as a decimal rather than as a fraction. Okay, so I recommend writing this down. Just a formula. So I'm going to give an example of how we use this as a calculation. So you don't have to write out the question, just sort of follow along as I go along. So this is my example. I'm going to make 2 columns because I'm going to do an example, and then we're going to go on to a practice problem where you're going to do it. So I'm going to do 2 columns, and then we're going to have it so it's like side by side so you can see the example as well. Line's not very straight, that's fine. Okay, say we have a car of mass 800 kilograms is traveling with a kinetic energy, I'm just going to write KE for short, of 1.44 megajoules. Calculate its velocity. So the very first step that you have to do in any sort of problem, because a question might not actually tell you this is a kinetic energy question, this is a gravitational potential energy question. It might not be able to be, like, it's probably not as obvious. You could work it out from the question itself, but what I recommend is just to make a list of all the values and convert anything as necessary. So we have a mass. I'm highlighting it as I go along. So any values they give me, I'm highlighting them. They gave me a mass, 800 kilograms. Is traveling with a KE of 1.44 megajoules. Remember, guys, when it comes to all of our formulas, the correct unit that has to go in is just a regular joule, not kilojoule, not megajoule. It's just a regular joule. Mass is in kilograms, and velocity is in meters per second. So mega means 1 million. So if I have 1.44 megajoules, how many regular joules do I have? Because that is the unit that I have to put into the formula. You should have calculators on your computers to do this. If one megajoule is equal to 1 million joules, how many regular joules do I have? Spot on. So if I were to pull up a calculator, I just times it by a million. So 1.44 is what I have, times by 1 million, and that is 1,440,000 joules. So I'm just going to write that. Regular joules. And that would be what I put into the formula. And it also says calculate its velocity. I'm highlighting that because that's what I need to find. So velocity equals question mark. Now the first step in our FIFA method is we have to state the formula. Now the reason why we do this is because when we substitute things in later, it's a lot easier when we have the formula right in front of us as a reference point to substitute things in and move like systematically from left to right rather than missing any values. Because on a question like this one, they're not going to give you the formula flat out. You're going to have to write it down yourself, and it's a lot easier writing it down and then substituting it rather than trying to substitute in your head in a formula that's in your head. So don't skip this step, even though it might seem like it's a little bit tedious. Get into the habit of writing out the formula. So I'm writing out KE equals 0.5 mv squared. And plus, if you write out the formula again and again, it makes it easier where you then memorize it without even thinking about needing to memorize it. Hang on guys, sorry, I just need to quickly put my mic on charge because it's low battery. Okay. The velocity, that's what we need to find from the question. It says calculate its velocity. So I've written velocity equals question mark because that's what I'm trying to find. They gave me kinetic energy. They gave me mass. And now I'm going to be later on rearranging to find velocity. So we're into substituting things in. So I in FIFA is insert. And just to make sure I do everything properly, instead of accidentally missing out any values, I'm going to look at the formula and I'm going to go from left to right. And anytime I see a variable, so like a letter instead of a number, I'm going to look at my list of values and check if there's anything that matches. So the very first sort of missing thing is KE. Then I look at my list and I see, right, do I have a KE already written down here? And then I notice I do. KE equals 1.44 megajoules. But remember, you have to put in the one with the correct unit. So I'm going to write out the full 1 million such and such. So instead of KE, I'm directly substituting, just like in maths. Do I have enough zeros? Yes, I do. Then 0.5, that's just a number, so I could just leave that the same. Then M, once again, I look to see if I have something for M, which is mass. My mass, I do. I have 800 kilograms. So I'm substituting in 800. And then I have nothing for velocity. I don't have a velocity. So I'm going to leave that as just a letter, v squared. So I've already gotten 1 mark for this now. At this step, I've gotten a mark. I've secured the mark. Now, though, I have to use my calculator and fine-tune it. So clean it up a bit and be able to get velocity at the end. Okay. Let me just rewrite out this so then I can show you and give you some tips on how to clean this up. Right. So the end goal is, at the end, I want V equals something. Yeah, I want V equals a number. That's the end goal here of what the whole point of this question is. They ask me to find velocity, so at the end I need V equals something. Well, looking at what we're starting with, it's a bit messy, so I need to do step by step, work out how I get V equals something. Just like in maths, you're solving. The very first thing I recommend you do is look on either side of the equal sign and check if there's any numbers that you can combine to make one number, so then you can clean it up a bit. On our left-hand side, we only have just one number. It's a big number, but it's just one number. It can't combine with anything yet. But on the right-hand side, I have 0.5 times 800 times V squared. Well, I have two numbers here, and instead of just having two separate numbers, it'd be a lot easier for me to just work with one number only, rather than two separate ones and trying to rearrange it that way. So I'm just going to put in my calculator 0.5 times 800 to get it to be one number. And if you put in your calculator 0.5 times 800, you should get 400. You can check that on your calculator now if you'd like. So 0.5 times 800, if I combine those, it would make 400. And then I just write the times V squared at the end. Okay, now it looks a lot neater and a lot easier for me to be able to rearrange and clean this up. Remember back in maths, what you're told in terms of how to solve for something is you're trying to isolate the variable. You're trying to isolate v and get it on its own. And in order to do that, you have to get rid of anything on the same side as v and move it to the other side. So there's a 400 here times on the same side as my v. So I'm going to get rid of it by doing the opposite. And because this 400 is times on, let's remember what we have to do to get rid of it. So just as a recap from maths, because it's times 400 here, if I divide by 400, I would be able to cancel it out. So these two 400s cancel out. But remember, anything I do on one side of the equal sign, I have to do on the other side. So because I divided by 400 on my right-hand side, I also have to divide by 400 on my left-hand side. Now I'm going to stick this thing here into a calculator. Remember, on all tests, you are allowed a calculator, so you don't have to worry about being able to do like the actual calculations and the working with the number itself. 1440000 divide by 400. That's 3,600. So instead of having that thing, I'm going to write 3,600 equals v squared. Okay, now remember, this is a bit where a lot of students mess up on in terms of this particular formula. There's a squared here. I'm not looking for calculating velocity squared. I just want pure velocity. So, in order to get rid of the squared, what's the thing I have to do to make it opposite of squared, to get rid of that squared? Think back to maths now. Spot on, Lauren. You square root it. So if you square root a squared, it pretty much directly cancels out the squared. So you're left with just plain old regular v. But anything you do on one side, you have to do on the other. So I have to square root my 3,600 as well. I'm going to put that in my calculator. I don't usually use this. Oh, there's that number. 3,600 square root. That is 60. And I know that I finish because my variable has now been fully isolated. I have just a v and then one number on the other side. So I have a value for v now. V equals 60. And that is my velocity. So my final unit is meters per second. So that my final step is just stating the answer, which we've done here. Okay, just to recap what we've done. Remember, this FIFA strategy is the same no matter what equation, what formula you're working with. You always start off by making a list of anything the question has given you. So like read through the question, each bit, each time you come across like a number and a value, highlight it, underline it, whatever, make a list on the side like we've done here. And then make sure you also write down what you're trying to find with a question mark. Then you write out the formula. This will make it easier for you to substitute in later, because then you can just work from left to right rather than trying to substitute in your head and do 2 steps in one go, because that makes it easier for you to make a mistake. Then insert the values just from your list, working left to right. You already get a mark for that. And then the next step is just like you do in maths, no different, nothing. You don't have to know much science to do this bit. You're just trying to find the missing variable by doing the opposite, doing the same on the either side until you cut it down and you get a variable at the end. So I'm going to put an example for here for you guys to do. Right. Serena Williams serves a tennis ball at a velocity of 60 meters per second and gives it 90 joules of kinetic energy. Calculate the mass of the tennis ball. Okay, so that's the question you guys are going to try to do. Serena Williams serves a tennis ball at a Serena Williams serves a tennis ball at a velocity of 60 meters per second and gives it 90 joules of kinetic energy. Calculate the mass of the tennis ball. What I recommend is when you get to the fine-tune bit, remember, clean things up first. Any sort of numbers that you can combine together or to just make one number, make it so everything is clean. So then when it comes to the rearranging bit, you don't have to do much. You don't have to rearrange one number at a time. It makes it a lot cleaner. Okay, so I'll give you a few minutes to do that, and then we're going to go over the answer. And then show you guys some practice for you to be able to do. What? I'm muted. What? Huh? I can't. I'm muted.
I said mute the screen.
I'm just changing my mic output because it's not picking up the right mic.
Okay, it's the right one now. How are we doing with this example? Lovely. Okay, I'm gonna go over it a little bit. So first step, Ke equals 0.5 mv squared. That's my formula. Then I'm gonna, the first step should be making a list of things. So Serena Williams serves a tennis ball at a velocity of 60. So V equals 60 meters per second and gives it 90 joules of kinetic energy. Ke equals 90 joules. Calculate the mass of the tennis ball. So mass equals question mark, and my formula is Ke equals 0.5 mv squared. Right, now substituting in from left to right. Ke, I look at my list, I see it's 90. 90 equals 0.5. I look at my list for m and I see a question mark, so I'm going to leave it at that. 0.5 m. And then I look at my list for v and I see 60. So that's 60 squared. One thing you do have to note is that the squared only belongs to the v. It's not squaring the whole thing. So on my right hand side, as you notice, it looks a bit confusing, so I have a lot of cleanup to do. To make it easy for myself, the one thing that I'm going to do is square the 60 first. So 90 equals 0.5 m, and then these are all times done, remember. So just to make it clearer, 60 squared, or 60 squared is 3,600. I also can clean this up a bit more by timesing my 0.5 onto the 3,600, because remember, when it comes to maths, these three things, 0.5, m, and 3,600, are all times together, and it doesn't matter which order you times things in, like 2 times 3 times 4 is the same as saying 2 times 4 times 3. So if I just times the 0.5 with the 3,600, that should combine into one number. (1,800) m. Now I have to rearrange by moving my 1,800 to the other side to make it so it's just m on its own. Anything I do on one side I have to do on the other. Those cancel, and m is 90 divided by 1,800. and that's 0.05 kilograms is my final answer. So that should have been the final answer, 0.05 kilograms. Anyone stuck on how I got 0.05? Are we okay with that being the final answer? Alright, so here is a link. If you go to that link, I'll pull it up now. If you go to that link and you click on kinetic energy, you should see a document here. Okay, I'll do another example of just for people to know where to find practice. There's two documents. One is just practice, one with the answers. Okay, I'll do another example. Let's do it from the first question here. A greyhound has a mass of 35 kilograms and can run at a speed of 20 meters per second. What is the kinetic energy that a greyhound can achieve? Let me rewrite the question here. Hang on one sec. A greyhound has a mass of 35 kilograms and can run at a speed of 20 meters per second. What is the kinetic energy that a greyhound can achieve? Okay, so remember the very first step is to make a list of all of the values that you have, that you are given, and work, like, don't get overwhelmed by all the information on the question. Do it line by line. So anytime you see a number and like a value like mass or speed or energy or something like that, make a list of that. So a greyhound has a mass of 35 kilograms. Right, I spot a number there, 35 kilograms. I'm going to look at the question and I see that that is a mass. So it's mass of 35 kilograms. I've underlined that and I'm going to make a list. So mass equals 35 kilograms. And can run at a speed of 20 meters per second. Speed is the same as velocity at this point. Speed of 20 meters per second. So speed equals 20 meters per second. What is the KE? That is what I'm trying to find. So KE equals question mark. So that is my list now. Next thing I'm going to do is the start of the FIFA method, where I start off with my formula written. So then I can work from left to right, once again, one step at a time, to make it easier for me to substitute things in. So KE equals 0.5 mv squared. That is my formula, and one thing that you do have to remember, you can write this out as well if it makes it easier for you, but remember, like in algebra, when you have the letters and everything, there are times symbols here that we don't really write. So 0.5 mv squared means 0.5 times m times v squared. So if you're more comfortable with writing out the times symbols, that's completely fine. It just might make it harder to memorize. Entirely up to you though. Okay, so I've written out my formula. Now I'm looking at my formula, and for each sort of bit of the formula, I'm seeing if I have a value for it given from my question. If I do have a value, I substitute the value in. If I don't have a value, I'm just going to leave the letter as it is. So KE, I have nothing. So I don't have a KE. I'm going to leave it as it is. Next bit of the question of the formula is 0.5. That's just a number, so I'm just going to write that number again. Next bit is an m. I'm checking to see if I have a value for m. I do. It's 35 kilograms. So 0.5 times 35 kilograms times my next bit is a v, and that is squared. I do have a value for v, which is velocity slash speed, and that's 20. So careful, this is going to be 20 squared. Then I just cleaned it up using my calculator. So you don't have to be able to like do this yourself on a piece of paper, like try to calculate this out yourself. You've already gotten a mark for this. The next bit is just cleaning it up on a calculator. I recommend, remember, doing BODMAS. You do the order first, so you do the 20 squared first before anything else. That's 400. So 0.5 times 35 times 400. And these are all times, so I can just stick this whole thing in my calculator, or I could do it in parts, up to you. I'm going to do it in parts just to show you how, like, rather than doing it all in one step. Okay, and that would be my final answer. This question didn't actually have much rearranging, so I actually I want to do another example that is rearranging. Okay, the next one on that sheet would work. Let me pick another one that has rearranging. When a bulldog is running at full speed, it has a velocity of 3 meters per second and a kinetic energy of 112.5 joules. What is the mass of the bulldog? Okay, Once again, very first step, make a list of everything you have. So when a bulldog is running at full speed, it has a velocity of 3 meters per second. That's a number that they've given me, so I'm underlining that. So velocity, I'm just going to write v. V equals 3 meters per second. And a kinetic energy of 112.5 joules, that is a number. I'm underlining that, putting it in my list. Kinetic energy is 112.5 joules. What is the mass of the bulldog? That is what they're asking me to find. So I'm going to write mass equals question mark. Once again, start off the FIFA method by writing out the formula. KE equals 0.5 mv squared, and if you'd like, you can write the time symbols in there. Up to you. Okay, working from left to right now. KE, I'm going to look at my list and see if I have a number for KE. I have V, KE equals 112.5. I do have a number for KE, so I'm just going to substitute that directly in. Next part of the formula is just a number, 0.5, so I'm just going to leave it as just a number. There's nothing I need to substitute in that part. Next bit is an M. I'm checking to see if I have an M, and I don't. So I'm going to leave that as just M for now. The next bit is a V squared. I do have a value for V. Make sure you put the squared there. So that is my substitution. All I did was just directly put in any numbers I had into my formula. So you'll notice that I had a KE, I've put the 112.5 in the same place as where KE was. The 0.5 is a number, there's no substituting in there, so I left it at that. Then I had my M, which I don't have a value for, so I'm leaving it as M, and then V squared. I have V, so I just got to put it in as the squared, 3 squared, instead of just 3. Now, the next bit is to clean it up and fine tune it. So on my left hand side, it's pretty cleaned up, it's just one number, so I'm leaving it at that. But my right hand side is a bit messy, so I'm going to clean it up step by step. Well, the first thing I could do is I could change the 3 squared into 3 times 3, which is 9. And you have to do that bit first anyway, because remember, BODMAS and in maths, anytime you see a power, you have to do that before you do any timesing. So 0.5 times m times 9. The right hand side is still not fully cleaned up, and the reason why I say that is because we have 2 separate numbers on either side. It would make it kind of annoying to rearrange it and swapping sides when you have 2 sets of numbers there. But remember, because even though like 0.5 is at the front and 9 is at the back with an M in between, it doesn't matter what order you times things in. Like 1 times 2 times 3 is the same as 1 times 3 times 2. You could swap the orders of anything when it comes to timesing, and you'll still end up with the same answer. So I'm going to swap my 9 and my m. I'll write this here just so then you could see clearly. I'm going to swap my 9 and my m just so then you can see that I'm timesing my 0.5 and my 9 together, and the reason why I'm doing that is because if I times them together, I could just end up with one number. I don't have to end up with two separate numbers that I gotta later try to rearrange. So I want just one number out of this to make the rearranging bit a lot easier. So referring to my calculator, 0.5 times by 9 is 4.5 times m. Now that is cleaned up, but remember at the end I want to solve for m. I want m equals something, and if you notice there's a 4.5 there, I gotta move it in order to isolate m and get m on its own. And to do that, I do the opposite of what it is. So because this 4.5 is timesed on, I'm going to do the opposite. I'm going to divide it. That cancels out. But anything I do on one side, I have to do on the other. So I got to divide both sides by 4.5. Because these 4.5s canceled out, all you're left with on the right hand side is m. My left hand side, I can refer to my calculator because no way am I going to do that in my head. 112.5 divided by 4.5. And that is equal to 25. So m is 25. My final answer, remember the units, is my mass is equal to 25 kilograms. Okay, so in terms of what to do, remember, you start off making a list of anything that the question has given you, all the numbers that the question has given you, but what value it represents as well. So when you make the list, don't just write 3, 112.5, because you're not going to know, okay, what is that 3? What is that 112.5? It's like if I've just done this in my list, well, I don't know what that 3 means. I don't know what that 112.5 means. So always make sure that you write the actual, like what those numbers represent. Then you write out the formula to help you with substituting. If you are more comfortable with writing in the time symbols, obviously feel free to do that. Then you work from left to right in using your formula and just checking each sort of letter and seeing if you have a value for it from your list. If you don't, you just leave the letter the same. So we worked on KE first, then we worked on the 0.5 and that was just a number. Then we worked on the M, found there was nothing. Then we worked on the V and we substituted everything in. Remember, that's already a mark just for correctly substituting things in. Then we worked on cleaning things up according to BODMAS. And remember, you can always rearrange anything that is times just to make it so things combine into one number. Because if you notice, we just did one step of rearranging. We didn't have to do any other steps of rearranging multiple numbers if we just combined it into one number. So we cleaned it up and then did one final step of dividing both sides by 4.5 to isolate our variable, and then came up with our final answer with our unit. So this is pretty much the exact same method as the gravitational potential energy equals mgh method. There's no difference to the method. It's still formula, insert values, fine-tune, answer. The main difference is obviously this formula, the kinetic energy formula, is a bit more challenging because you have a squared involved, but I can also say that in terms of all the formulas you're going to do in physics, this is probably the hardest type of formula, So if you feel confident with this, if you get to the point where you're confident with this formula, there probably won't be any other formulas that you do in year 10 or year 11 that you'd find challenging. This is the hardest type of physics formula there is because of that squared. But once you feel comfortable with that, then you're in really, really good shape to tackle the rest of calculations in physics. So on the website that I've linked, if you click on the kinetic energy section, you come up with the kinetic energy.docx by here. That is just the questions, and then you have the answers on the left one. So the answers are just at the bottom. Okay, so the answers are just at the bottom for you to check what you've done. On the question sheet, I've put some challenges in there. 3, 7, and 8 are challenges because you have to do the equation twice. Like for example, Boris Johnson has a mass of 85 kilograms and Donald Trump has a mass of 108 kilograms. If both are traveling along a zip wire at 50 meters per second, what is the difference in their kinetic energy? So for a question like that, I want you to find the kinetic energy of Boris, find the kinetic energy of Donald, and then subtract them to find the differences in their energy. So those are the main types of challenges that I would have on there. No other types of challenges. Question number 8, find the kinetic energy separately and then add them together. Question 7, difference in the velocity, same thing. Find the velocity of one, find the velocity of the second, and then subtract them to find the difference. So you don't have to do all of these. Remember, these are this is all completely optional. The only thing that is mandatory that you have to do in terms of the science department is make sure you hand in the topic tests that are set and doing your educate. Everything else is just to be able to help you feel like you're not so stressed out where you have to do this on your own. And even if it's not about the energy topic, feel free to email me at any time and say, Miss, I'm struggling with electrolysis, or anything you're struggling with, just let me know. I'm more than happy to answer anything that you have in an email or anything like that. So you do have the answers on here for you. I'm going to leave it at that. If there are any questions, if there's one where you just can't seem to get how I got my answer, I could have made a mistake as well. If you just don't know how I got a particular answer, you can't seem to get it, feel free to leave a comment on the YouTube channel, or you can also email me or send me a message on Show My Homework, and I'm more than happy to just quickly go over that problem for you. Okay? So, hope you guys have a great rest of your day, and try to do as much practice as you can on this, and hopefully we feel a bit more confident in the topics that we're doing, because it is difficult learning a lot of stuff from home, and I'm really, really proud of you guys for sticking this through. Okay, I'll see you.